Sorry about that. Okay. So there are two new theorems we have to memorize. When it's a theorem, are we allowed to say definition of? No, we're not allowed to say definition of. So I'm going to go through the theorem. I'm going to explain the theorem to you, what it means, and then I'll tell you the shortcut that we're allowed to write in proofs. So the theorem says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. What does that mean? This is saying if I have a triangle with the legs congruent, if the legs are congruent, it's essentially what kind of triangle? An isosceles triangle, exactly. So if I have an isosceles triangle and the legs are congruent, what we can conclude that the base angles are also congruent. We can conclude that the base angles are also congruent. So if the legs are congruent, then the base angles are also congruent. All right, the shortcut for this that we are going to write in proofs, the shortcut is going to be if, and now you draw a picture of a triangle with the legs congruent. You write the word then. And now you draw a picture of a triangle with the base angles congruent. So if the legs are congruent, then the base angles are congruent. All right, so now the next theorem is just flipping this. So now they're saying, okay, well, let's start off by saying that the base angles are congruent. If the base angles are congruent, guess what we can conclude? That the legs are congruent. Exactly. Shortcut. Anybody think they know how we're going to write out the shortcut? Sion?
If legs congruent, or triangle legs, or sorry, if triangle angles congruent, then triangle legs congruent.
Good. If, and then we draw a picture of a triangle with the base angles congruent, then now we draw a picture with the legs congruent. Should you memorize these?
Yes.
Yes. Can you just memorize the shortcut? Is that okay?
Yes.
Absolutely.
But sometimes it helps to write the full theorem.
It does. Sometimes it does help. I agree with that. All right, we ready? All right, this next theorem you do not have to memorize. It will not be used in proofs. It will only be used in algebra problems. So you just have to understand it. You don't have to memorize it. Just get an alcohol wipe, Sam. Okay, so what does this theorem tell us? I'll read it to you and then I'll explain it to you. It says if two sides of a triangle are not congruent, then the angles opposite them are not congruent, and the larger angle is opposite the longer side. What does this mean? All this is saying is that if I have a bigger angle, it's going to take a longer side to close it up, versus if I have a smaller angle, it will take a shorter side to close it up. And that makes perfect sense. You don't have to draw this. I'm just showing you. Let's say I have a large obtuse angle versus a smaller acute angle. To close up that larger obtuse angle, wouldn't it take a much longer side to close it up versus closing up a smaller acute angle? Wouldn't that take a shorter side?
Yeah.
All right, that's all this theorem is saying, is across from the larger angle will always be the longer side, and across from the smallest angle will always be the shortest side. So let's say I have triangle ABC, and let's say angle B is 100 degrees, angle C is 30 degrees, and angle A is 50 degrees. Out of these three angles, which angle is the biggest? Sam? B. B is the biggest. So according to this theorem is across from the biggest angle has to be the Longest side. So that means out of the 3 sides, which side has to be the longest? AC has to be the longest side. So across from the biggest angle is the longest side. Where would or which side would be the shortest side, do you think, and why? Mia.
AB, because it's across from the 30 degrees.
You got it. AB, because it's across from the 30 degrees. So this is our shortest side. All right, so I told you that we will not be using this theorem in proofs, that we'd be using it in algebra problems. So let me show you how this might be used. All right, given side AC is greater than AB. Well, if AC is greater than AB, which one is longer? AC greater than AB. Which one is longer? AC. So I'm going to write over here, AC is longer. So that means AB is shorter. Well, now let's make a conclusion. If AC is longer and AB is shorter, which angle is bigger and which angle is smaller? Finn?
Angle B is bigger and angle C is smaller.
You got it. Angle B is bigger and angle C is smaller. Why? Sam?
This doesn't have to do with that since B is the bigger angle. You look across from it and that's the longer angle.
Good. Across from the bigger angle will always be the longer side, and across from the shorter angle will always be the shorter side. Smaller angle will always be the shorter side. All right, let's keep going. They're telling us angle B plus angle C is less than 180. That makes perfect sense. Why does that make perfect sense that angle B plus angle C will have to be less than 180? Julia?
Because all 3 angles have to add up to 180.
Excellent. All three angles in a triangle have to add up to 180. So any 2 angles, the sum of any 2 angles, won't it always have to be less than 180?
Yes.
All right, let's keep going. Then it's telling us angle C is represented by 15 plus x. And angle B is represented by 6x minus 45. Aw, so if you have the hiccups. All right, now my question to you is, what are the restrictions on the value of x? So when I ask you for restrictions, how many answers do I want?
1, 2. Wait, 2.
2. We want 2 answers. We need a number it's smaller than and also a number it is greater than. Well, look at our diagram. Doesn't angle B have to be bigger than angle C? So that's where I'm starting off here. I'm going to say angle B is greater than angle C. Well, angle B is represented by 6x minus 45, and that has to be greater than 15 plus x. And now let's go ahead and solve this inequality. So I'm going to subtract x on both sides. So we're going to have 5x minus 45 is greater than 15. I will now add 45 on both sides. So 5x is greater than 60, so x has to be greater than 12. All right, so we got x is greater than 12. Am I done with this problem? No. So we found a number x has to be greater than. Now I have to find the number x is less than. Go back to the given. Didn't it tell us angle B plus angle C is less than 180? Yeah, that's going to be our next restriction. So we're going to write that out. Angle B plus angle C has to be less than 180. So we are at 6x minus 45 plus 15 plus x is less than 180. I'm going to combine my like terms. So we're going to get 7x minus 30 is less than 180. Let's add that 30 over. So we are 7x is less than 210. So x has to be less than 30. We found a number it's greater than. We found a number it is smaller than.
Oh, so this is what we did a few chapters ago, right?
The restrictions?
Yeah.
Yeah.
That was on the little smaller triangle.
So those were on like acute and obtuse angles, and now we're using it on triangles. But same idea. Whenever I ask for restrictions, we need two answers.
Will restriction be on the test?
It's fair game. I'd expect it, yeah. All right, let's keep going. All right, let's do some proofs. Are we still laughing at her hiccups?
No.
Poor Soph.
I'm laughing at Adrian because he loves proofs.
I don't know, y'all are pretty good at proofs.
But they're tedious.
Did you say it takes a while?
They're very tedious.
I don't know for all this.
They're thought-provoking. Okay, so triangle JOM is isosceles with vertex angle JOM. Is it important that I told you extra information about the isosceles triangle?
Yes.
Yeah, because it helps us come to the conclusion of which sides are congruent. So if the vertex angle is angle JOM, which sides have to be congruent?
OJ and ON.
You got it. So my next step is going to be that OJ and OM are congruent. So we're going to say OJ is congruent to OM, and our reason is going to be def of isosceles. Okay, let's keep going. Now it says that OK bisects angle JOM. We can make a conclusion there. If we're bisecting angle JOM, what can we conclude? Looking for somebody else. Looking for somebody who doesn't normally participate. Danya? You got it. If we're going to bisect an angle, we're going to get two congruent angles. So we are bisecting angle JOM. Go to the middle letter O, go inside. Do we see two angles inside? Can I call them 1 and 2? Yeah, so I'm going to say angle 1's congruent to angle 2. And the reason will be def of bisect. You got it. Now, I would say about 99% of you at this point would then say, okay, reflexive, right? Okay, reflexive. That's absolutely correct. You're good. If you did that on the test, you'd be great. I want to do it a different way, just to show you something new. All right, so everyone look at triangle JOM. Do we see that triangle, the big triangle? In that big triangle JOM, are the legs congruent? Yes. If the legs are congruent, what else, based on the new theorem we learned, can we conclude are congruent? Then the base angles, right? The base angles. So I'm going to say angle J is congruent to angle M. So step number 4, angle J congruent to angle M. Who thinks they remember the theorem that goes with this? Oscar?
If triangle with legs congruent, then triangle with angles congruent.
The base angle's congruent. You got it. Oh, thanks. Okay. Now the triangles are congruent by what method?
Angle side angle.
Angle side angle. So I'm going to say triangle JOK congruent to triangle MOK, angle side angle. Now let's look. I forgot to do this before. What are we trying to prove? We are trying to prove that OK is the median. If OK is the median, what would I need to show? If OK is the median, what would I need to show? Simon.
You would have to prove that, you have to prove that,
What does a median do? So OK is a median, what does it do?
oh, you have to prove that angle JKO is congruent to...
Not angles, no.
No, JK
Yep.
of KM.
You got it. Doesn't a median split a segment into two equal parts? So if we're going to prove OK is the median, am I allowed to just say that right now that OK is a median? No, all we've done is prove triangles congruent. In order to prove that OK is a median, I need to specifically say that JK and KM are congruent. We don't have that written down yet, but can I now write that down?
Yes.
Yeah, for what reason?
Corresponding parts of congruent triangles are congruent.
You got it. JK congruent to KM, CP, CTC. Now that we've showed JK and KM congruent, now we can say that OK is the median to the base. And that's just def of median. Mia?
Couldn't we have concluded that JK and KM by the given because OK bisects JO?
So the given tells us that OK bisects an angle JOM. So when you bisect an angle, you only get congruent angles. So that's how we got 1 and 2 up here to be congruent. But we can't assume anything about the segment because it only spoke about the angle. Hey, I'll give you a second to finish copying, then we'll go on to number 3. Anybody still copying? All right, number 3, let's go. Let's do this. All right, so here we have angle E is congruent to angle H. Stop right there. Angle E and angle H, are they base angles? If yes, of which triangle? E and H, are they base angles? If yes, of which triangle? Cyan.
Triangle DEF and triangle DG.
No. So they have to be base angles of one single triangle. They can't be base angles of two different triangles. DEH, you got it. We all agree that E and H are base angles of the triangle DEH, just one triangle. They can't be base angles of two different triangles. They have to be base angles in the same triangle. So now that we have the base angles congruent, can we conclude legs are congruent? Yeah, which legs? Which legs, Max?
Segment DE and segment DH.
You got it, segment DE and segment DH. Who thinks they know the reason for this? Michael? You got it. If we have a triangle with the base angles congruent, then we have a triangle with the legs congruent. Sam? Did you watch my video, the 3-6 video?
Yeah, it was 8. Oh, okay. So it's like the small. Okay. Yeah.
So legs are, you want to go back because that explains all the definitions. You want to go back and watch my 3-6 lesson. But basically, legs are the sides of an isosceles triangle that are congruent.
I just want to make sure
Okay, so now let's keep going through our given. EF is congruent to GH. What is it that we want to prove? We need to prove that DF congruent to DG. As of right now, can I prove DF congruent to DG?
No.
No. So I need to prove
Triangles.
triangles. Max, which triangles do you think?
Triangle EDF and HDG.
You got it. Now look at the markings. Are we able to now state these triangles are congruent?
Yes.
Absolutely. So let's go ahead. We're going to say triangle DEF congruent to triangle DHG, side, angle, side. And then lastly, we can say that DF is congruent to DG, and that's a simple CPCTC. Anybody still copying? Okay, this is the last one we're going to do together. Then I have one for you to try on your own. Diagram got a little shifted. So angle 3 is actually angle XBT. So that's that angle right there. And angle 4 is actually angle YAT. That's that angle right there. All right, so here we have angle 3 congruent to angle 4. So let's mark it. Then we have that BX is congruent to AY. Mark that. And last piece of given information is that BW is congruent to AZ. Mark that. Mark that and then pay attention to me because I'm going to have a little chat. Now, we are trying to prove that triangle WTZ is isosceles. In order to prove triangle WTZ is isosceles, we need to show two sides congruent. If we show two sides congruent, then we can say it's isosceles. I will tell you, moving forward, from this day forward, the most likely way to get sides, legs congruent is to prove base angles first. So that's usually how things are going to have to work. So I want to get WT and ZT congruent. The way I'm most likely going to get WT and ZT congruent is to first get angle W and angle Z. So more likely than not, majority of the time, if I'm asking you to prove a triangle's isosceles, you're going to go the base angles to legs route, usually. That's usually the route we're going to have to take. Okay, with that said, we all agree at this point we cannot prove WT and ZT congruent. So we have to prove triangles congruent regardless. Does anybody see a pair of triangles that we can get congruent? Antonio.
Triangle WBX and ZAY.
You got it. So these two triangles, at this point, I only have two sides. 3 and 4 are outside of the triangles. Does anybody see how 3 and 4 can help us get angles inside the triangles? Daniela. You got it. I can call this angle 1 and angle 2. So step number 2, I'm going to say angle 1 is a supplement to angle 3, and angle 2 is a supplement to angle 4. Def of sup. And then where are we going with this? Angle 1's congruent to angle 2y? Mia?
Subs of congruent angles.
You got it. Subs of congruent angles are congruent. So now I can say triangle WTX, oh, not WT, sorry, WBX is congruent to triangle ZAY by side angle side. Can I see PCTC, WT, and ZT?
Wait, no.
Why no, Simon?
It's because that's because they're not consumed by the
Triangles.
segments of the already congruent triangle.
You got it. These congruent triangles are too small. WT and ZT, they're bigger than those triangles. They're not sides of those triangles, so we can't see PCTC them. So what did I say the game plan was? We can get the legs congruent by first getting the, Max?
Base angles,
The base angles. What two base angles do we need?
W and Z.
You got it. Can we see PCTC, W, and Z?
Yes.
Yeah, so step number 5, angle W is congruent to angle Z, CPCTC. Now we can get the legs congruent. So we're going to say WT congruent to ZT, and that's going to be that new theorem we learned. If base angles, then legs. Now that we got the legs congruent, can we now say the triangle is isosceles? You got it. Def of isosceles.